time for that, and as you see here, because I'm not especially competent to do that. I'm most definitely not going to eulogize his achievements, because he wouldn't want me to. He was a person who truly and sincerely eschewed academic fame and academic impact. He often quoted his father. His father was a famous architectural sculptor, Allen Parducci. There is even a society of Parducci that gathers the fans of Allen's father. And Allen was quoting him saying, public spaces are full of food spaces. And the context of this quote is that public fame is often fake. If you look it up, this particular quote or variants of it on internet, you will find other interpretations of it. But this one probably came. Allen was a co-inventor and pioneer of windsurfing. If you didn't know that, it's a remarkable achievement. Allen, when he died, he was 97 years old. And he sailed and bicycled almost to the last of his days. Later, in later couple of years, he mostly tricycled. It is still physically demanding. He considered sailing and cycling no less important activities than his academic career. And it was his genuine attitude and genuine belief. He was an admirer of Henry Thoreau's Walden. I don't know whether everybody here is familiar with that, but you should look it up if you're not. He admired this work even though he himself would not be able to live a life of isolation. He was extremely sociable, curious about other people, always engaging them in conversations. Even in Paris metro, underground, he was talking to people around him, engaging them in lively discussions. He often said that if he could afford it as a young person, he would never publish, never pursue academic career, and instead would spend his life traveling and talking to interesting people. That was his kind of attitude towards life. Well, this is a meeting of mathematical psychologists, and so I am supposed to relate it somehow to mathematics. And in my 40 years of knowing Allen, we had many fruitful and interesting discussions about mathematics and measurement. He shared very interesting observations and insights with me. However, it would be difficult for me to present any of those. My memory may not also be very good about all of these things, we didn't recall them. But in his professional work, Allen was not a mathematical person, so by no stretch, he could be called a mathematical psychologist. He was a psychophysicist of the old school, and his work did not involve intensive mathematics or even statistics. His attitude to mathematical psychology I would call to be respectful skepticism. But once it happened that we discussed a straightforward, simple mathematical question. And when I was thinking about what would I talk about at this meeting, it occurred to me that would be a good choice, because it is a very simple problem, and it, in a certain way, kind of reflects the way he approached various technical problems in his work. So, this is my introduction. And now I will begin my talk, right? Which I entitled Parducci frequency. You see this formula already here, so let me explain what it is, right? So you have a set of sorted observations. So you convert them in numerical way, in numerical form, and sort them from the least to the largest. And as you see, I just chose here arbitrary values. And then you look at their ordinal position. So this is the first value, the second set, and there are the total of 8 values here. And then you assign cumulative frequency to that. So the cumulative frequency is assigned according to a certain formula that Allen used in his work. You take the ordinal position of the observation, subtract 1, and divide by the total number of observations less 1. Okay? So for the first one, the value will be 0 because you have to subtract 1 from 1. And for the last one, the value would be 1 because you are subtracting, you are getting the same value in the numerator and denominator. Okay? What is interesting about this is that if you add all these cumulative frequencies and compute their average value, the mean value, arithmetic mean, you get precisely 1/2. So these are the properties that he pointed out to me when he posed to me this question. You have a set of cumulative frequencies assigned or computed in such a way that the first one is 0, the last one is 1, and the mean value of cumulative frequencies is 1/2. What Allen was concerned was the fact that he couldn't find it in the literature, some kind of mathematical justification for that. He used it in his work perfectly well. It is in his book on happiness as well. And he asked me, what is it? What is the mathematical term for this? How one would justify this particular choice? And first of all, before I talk about what it is related to, let me make sure that we understand. Of course, there is nothing special about my example. If you I'm pressing the same button instead of going back. If you get any set of observations, sort them and assign the cumulative frequencies according to this formula, you necessarily get these 3 properties, and you can easily prove it by simple algebra that the mean always is 1/2, right? So it works. Moreover, if you look at any absolutely continuous distribution, let's say on the interval from A to B for simplicity, then it has exactly the same property. Obviously, it always begins with 0, ends at 1, and the average value is 1/2 by very simple calculus. Right? So Parducci cumulative frequency is actually a very good discrete analog of this fundamental fact about continuous distribution. Well, okay, so PCF stands for Parducci cumulative frequency. This is what we have with all the properties. Let's try to compare it with something. So let's try to look at cumulative frequency, how it is normally defined in most of the probabilistic literature. This is the probability with which the random variable assumes the value less than or equal to a given value, right? So if you look again at the same thing, at the same example that I've used previously, then you get the assignment as you see them, right? So it begins with not 0, ends with 1, that's fine, but the mean value is necessarily greater than 1/2. Again, it can be chosen, it can be proved in complete generality. So it is not what Allen Parducci's frequency is. So it is not a classical cumulative distribution function. Now, there are other possibilities of defining it. For example, this is just emphasizing what I've just said. But let's say we decided to define it in this way. strictly less than x. This is the definition of cumulative frequency that used to be the one that was in all rational language mathematical literature. And in this case, you get one of the properties that it begins with 0, but it doesn't end with 1, and the mean value is less than 0. Well, let's try something in between. This is one kind of obvious candidate for this. So you look at the frequency of values of probability of all values falling below, strictly below x, and then 1/2 of all values that equal x, right? Or frequency of those values that equal x. And then what you get is, well, nicely you get 1/2 indeed. But then you lose this beginning with 0 and ending with 1. Both of them are lost, right? And believe it or not, but you know, we spent considerable time, maybe around 3 hours in the evening in his fantastic house in Pacific Palisades in California. You know, in the evening, sitting on his balcony and discussing, you know, what could be done in order to fit his type of frequency. And at the time, we didn't come up with answers, right? In fact, even this one, I came up later with the value of 1/2. Well, by the way, you know, again, you can prove generally that this last definition of the cumulative frequency function would indeed have the value of 1/2. I see it somehow doesn't fit, but somewhere there it proves that it is 1/2. Right? Okay, so now we have this problem of the anchoring points of the beginning and the end. And okay, there is one possibility that can occur to someone, you know, to create these anchoring points artificially, right? In this way. So you simply add something below the lowest value and above the highest value, and assign to them 0 and 1, and then lo and behold, you have all the properties satisfied. When I mentioned that to Allen, he dismissed it right away, like totally nonsensical. And the way he argued is, well, suppose that it's not numbers, but you know, just categories like tiny, small, medium, large, huge. You know, you are inventing a category such that if you actually used it, for example, super tiny or you know, super huge or something. If you actually use them, you know, then you would not get 0 frequency at each of them, right? And as a result, it would not begin with 0 and 1. So it's kind of cheating, in his opinion, and you know, I have to agree with that. Completely correct. So, what is the problem with his definition? What one might consider to be a problem with the definition of cumulative frequency that Allen used? Well, the main thing is that it is not a function of value of the observation. So, you know, it is defined in terms of the ranks, ordinal ranks, but not in terms of the values. Okay? So that, for example, the first 2 values in this example are 2 and 2, and they are equal to each other, but the frequencies assigned to them are not equal. Right? So it's not a function of the value. Whereas all the other things that we considered, you know, the definitions of cumulative frequency, distribution function is a function of value. But again, if you think about it, all these other things, like, you know, I list them again here, they of course will give you one and the same, you know, value of probability mass or frequency mass at each of the values that repeats. So at 2 and 2, we will have always repetition of the values. It is okay, but still, if you transform these values in by any monotone function, you still get the same values of the cumulative frequencies, right? So it is a function of value, but not real of value, right? It is a function of value after that value was rank ordered, right? So the first conclusion is that Parducci cumulative frequency, and I'm not excluding the possibility, maybe someone will tell me, after I finish, maybe it's known by some name. Someone has used it too. Allen actually did not assume that it was anything original. But let me call it Parducci cumulative frequency is an original thing. It is a distinct way of defining cumulative frequency, distinct from the existing ones. However, what to do with the fact that they are not functions of value? Well, actually, there is no problem here, and it's not a problem of mathematics. In other words, you cannot say that because of that, this is some kind of a hack, experimentalist hack in mathematics, whereas the classical cumulative distribution functions are rigorous mathematical. No, it's not like this. You have to distinguish between ordered and unordered sets. Right? If you have unordered set, then the replications actually do not count. Right? So the set that I came up with will be exactly the same as the set indicated on the right here. Right? It's exactly that, the same unordered set. When you say ordered set, you impose a structure, and this structure, one way of understanding is that you are actually dealing with values associated with their ranks. Right? So 2 is not just 2, but it's 2 which is first, the other 2 is the 2 that is coming second, and with 3 sixes it is the same story, right? So it's actually a set of pairs. And the classical definition is using the rank ordering in the same way in which Allen's formula uses it. But Allen simply uses just the rank, so it is kind of a simplistic variant of this, and we get this formula. So this is what he taught me, right? That one can do it. And interesting thing about it is that he used it and resisted all ways of kind of suggesting something more sophisticated, because he was convinced that this is how it should be done, experimentally. And in fact, I think that it is the optimal way of dealing with experimental data if you want to do it, right? Parducci frequency. This is, I actually have taken very few photographs with Allen. It's a great pity, but this is one taken in Provence, in the place that was his favorite place in France, with his wife Debbie, and it was 11 years ago, and that's it.